Okay, everyone, this video we're going to be taking up the latest bonding and polarity quiz. So I just want to go through a couple items in terms of Lewis structures. Lewis structures are simple. You don't have to include charges or anything like that. You're just showing the position of the valence electrons and charges of ions if applicable. So let's take a look at this. We've got ammonium ions. Remember, ammonium is NH4, so I'm going to have nitrogen surrounded by 4 hydrogens. I'm not going to go through the long way right now. You could if you wanted to. And then just remember to put square brackets around on the positive side. If you don't have that, you lose half the mark, so keep that in mind. Calcium chloride, alarm bells going off in your head right now, because it's an ionic compound, which means that you're going to end up with calcium losing 2 electrons and each of the chlorines picking up 2 electrons. So a lot of you forgot about that, so be careful. Ionic compounds do exist. There's no sharing of electrons here. It's a give and take. You got the transfer from the calcium to the chlorine, okay? All right, sulfur dioxide. I already did the tally chart over here to help us out. Sulfur is the least number. It's going to go in the middle. Oxygen goes on the outside. Let's add the electrons. You're going to add 2, 4, 6, 8, 10, 12, 14, 16, and another one over here, 18. So we're all good with the oxygen. Sulfur, look at this, 2, 4, 6 electrons. So what do you have to do? You have to borrow electrons. You're going to be borrowing some of them either from this side or that side, which means we've got resonance structures. So when you're doing this, you have to be able to draw 2 diagrams. So here we go. Here's one possibility. So maybe the electrons are being borrowed here. So you have a double bond. You still have the lone pair there, and this side stays the same. Or maybe the electrons come from this side here. So then you'd have the following. All right? So you've got 2 possibilities here. And make sure you have the arrow showing the 2 resonance structures that are possible. Okay? All right, down here we had a couple more diagrams we're working on. These are the big ones. These are the ones you have to really make sure you do a good job with. So first of all here, I've got sulfur dibromide. So you do a little bit of work here. You figure out the difference electronegativity is 0.4, which means this is a covalent bond or non-polar covalent. Okay. Now the Lewis diagram, you're going to kind of draw it like this. There's your bromine. Remember, bromine has the lone pairs around it. There we go, just like that. What does the 3D diagram look like? The 3D diagram properly drawn would look like this. So you only have the lone pair around the sulfur. If you want to put the lone pairs around bromine, that's okay. I won't take marks off, but properly this is the way you should be doing it. You only include the lone pairs on the central atom. The shape here is going to be bent. And this is a non-polar molecule. And some of you are trying to put charges in here. Hey, if you've got a regular covalent bond, there are no charges. There's no delta negative or positive, so be careful. You lost marks as a result. All right, next possible one for you was, I believe, formaldehyde. We did this in class, so I should have remembered this one. Okay, give me a sec here. Oops, sorry. So formaldehyde, you look at the 2 bonds here. So let's take a look at both of them. All right, so here we go. So you're going to have this shape initially. So you're going to have your oxygen up here, a hydrogen here. This is the original Lewis diagram. Remember, you have to borrow a pair of electrons here to make a double bond to make carbon happy over here. So I'm going to get rid of this. Right. And you're going to be looking at 2 bonds here. You've got 1 bond over here. So the electronegativity here for this bond is going to, the difference is going to be 0.8. So it's going to be the carbon-oxygen bond. And this means it's a polar covalent bond. So make sure you write that out nice and long. Polar covalent. Which means we're going to have a negative charge here and a positive charge on the carbon. Then we're going to be looking at the next one. We're going to be looking at this bond here, these 2 bonds. Now these 2 bonds are going to be the carbon-hydrogen bonds. You look at the difference in electronegativity, it's only 0.4. So it's a non-polar, or just polar, or just non-polar, or just regular covalent. So there are no charges down here. Don't put charges in. Now the next thing we have to do, we have to draw the 3D diagram. You draw it like this. You've got this. There's 3 parts that are going around the central atom. So it means it's going to be 3-part trigonal. And then put the hydrogen here, Here it looks like it's flat, so it's going to be trigonal planar for the molecular shape. Now let's see what's happening in terms of the charges here. So remember, we're going to have a positive charge. It's on the carbon, not on the hydrogens. And up here, negative is going to be on the oxygen. So the pull of the vectors is towards the oxygen. So there's only one end that's negative. So this is a polar molecule. So make sure, again, you watch some of the videos. We've already done this before. This really should be review. And make sure you're able to identify the different shapes as well. Okay, and be careful with the polarity here. Don't put polarity in, for example, here, if it doesn't exist. That's it. Take care.